Hello everyone. The focus of today's lesson is about the antiderivative of exponential functions. And here I have 10 examples for you. I know that's a lot. Just want to make sure I cover everything. So hold on tight, bear with me. And don't worry, this is going to be uh, easy. I hope you learned something from today's lesson. All right, but before we proceed, if just in case you haven't watched the video about the previous lessons about antiderivatives, I encourage you to watch those videos because there are some things there that I believe are important in order for you to better understand this lesson. All right, so let's go to the first example and the second example. You can see the two examples here. And by the way, on the right side, upper right side of your screen, you can see the theorems about exponential functions that we will be using. So the first one, you can see there the integral of e raised to x dx. That will just be e raised to x plus c. For number two, that's an exponential term, a raised to x. A is any number that is not equal to 1. Okay, and it should be greater than 0. And that will be a raised to x over ln a plus c. And of course, the last one, the third, is x raised to negative 1. And that, I mean, the integral of x raised to negative 1, and that equals to ln of absolute value x plus c. All right, so let's answer the first example, 5e raised to x plus 2 raised to x. So here, what we will do is we will use the third theorem of the that's I think that's the third theorem, the basic theorem of anti-differentiation. So we will take out that 5. So this is going to be 5 integral of e raised to x and then plus, and we will apply that fourth theorem. So that theorem states that we can do this: separate 5 e raised to x and then plus 2 raised to x. This is dx plus 2 raised to x dx. So we all know that the antiderivative of e raised to x, as you can see here, is just e raised to x plus c. So that means this would just be 5e raised to x. And then plus the antiderivative of 2 raised to x. That's the second theorem, right? You can see it. So this is 2 raised to x over ln of 2 plus c. Alrighty. Okay, let's go to the second example. 3 raised to 2x over 3 raised to x. And you might be wondering, where is that in the three theorems? Well, first we need to apply that loss of exponent. You can see here the bases are the same. They are both 3. So meaning we can subtract 2x minus x, which means we can rewrite this as 3 3 raised to x dx, which means that the answer, we can now apply that theorem number 2. So this is 3 raised to x over ln of 3 plus c. There you go. All right, let's go to the third example. Okay, so the third example, we have 4 raised to x plus 1. Now, our understanding on how to manipulate exponential terms is very important and critical. Here we can rewrite this first as 4 raised to x times 4 raised to 1. Right? I know you agree with that. So what we can do is we can take out that 4 because that's constant. So 4 times the integral of 4 raised to x dx. So which means that this is going to be 4 times 4 raised to x over ln of 4. plus c. All right, which means that our final answer, 4 times 4 raised to x, will just be 4 raised to x plus 1 over ln of 4 plus c. And that is going to be our final answer. All right. Okay, so let's go to the fourth example, the integral of 2 over x. Again, it's very important that we understand the basic theorems in integration, or anti-differentiation rather, in order for us to answer the problems here. So if you can't catch up with my explanation, my advice is to watch those two videos first about the antiderivative of functions and antiderivative of algebraic functions. All right, and by the way, let's continue now. So here what we can do is we can take out that 2. So 2 times the integral of 1 over x dx, and that means we can apply the third theorem, right? So this is equal to 2 ln of absolute value of x plus c. There you go. We are now halfway through the examples. This is example number 5. Alrighty. So let's rewrite this first. 3 times the integral of e raised to x minus, wait, let's put the dx, minus 2x over x squared, right? Now this is going to be minus 2x divided by negative, that would be negative minus, and then that positive 1 divided by this negative, that would be minus. So wait a minute. So, there you go. Dx minus 1 over, I keep on forgetting that integral symbol, 1 over x squared dx. Alrighty. So first, let's integrate this first term. That will just be equal to 3 e raised to x. Nothing's gonna change there. Now, I forgot to put out that 2, but anyways, that will be fine. Let me just fix that. There you go. So x over x squared, that will be, we can simplify this and cancel 1x. This is 1 over x. And as you can see, we can use the third theorem. So this will just be negative 2. That 2 outside, 1 over x is ln of absolute value of x. Okay. Minus. So 1 over x squared is, we understand that that's x raised to negative 2. Okay. And using the basic theorem of anti-differentiation, what we will do is we add 1 to that. So I'm going to put that here. X raised to negative 2 plus 1 over negative 2 plus 1. Let's not forget the c. So our final answer is 3 e raised to x minus 2 ln of x, absolute value of x, plus, because negative 2 plus 1 is negative 1, that cancels out the negative. This will be positive. And then we want the denominator, or the exponent rather, to be positive. So this will be 1 over x plus c. There you go. 5 more examples. Let's go to this one. So e, or the integral of e raised to x plus 2 dx. Let me just rewrite this first. So this is e raised to x times e raised to 2 dx. Now we understand that e is a constant in math. That's approximately, I think, 2.7 something. So we can take that out. So e raised to 2 and e raised to x dx. And of course, we all know that the e raised to x is just equal to e raised to x plus c. So e raised to 2 times e raised to x plus c, which means that the final answer is e raised to x plus 2 plus c. Alrighty, let's go to the next example. And this one, it seems difficult. It's not, don't worry. I'll try my best to explain this to you. So what we will do here is we will expand this problem first, and so that it will be easier to integrate each part. Okay, so let's start with the first one. So by the way, I'll just do that here first. We understand that this is the same as 7 raised to 3x times 7, right? And then here, if we um, distribute or separate the terms here rather, excuse me, excuse me, so this will be equal to 1 or minus rather 3 3 raised to x 3x raised to 5 over 2x, and then this will be plus minus minus is plus x raised to 3 over 2x, and then plus again 1 over 2x. So what I did is I just separate them so that it will be easier for me to um, solve this one. Alright, so let's continue now. This is now equal to 7. I'll put that outside. Integrate of integral of 7 raised to 3x dx. And then this will be minus 3 over 2, right? X raised to 5 over x is x raised to 4 minus, or plus rather, this is going to be 1 half, and then x cubed divided by x is x squared plus dx. I forgot the dx. Hold on. Forgot the dx here. So plus 1 half x squared dx, and then plus 1 half, then 1 over x dx. Alright, so I know that's a lot of writing, but it's okay. Alright, so here the integral of this is 7 times um, 7 raised to 3x all over ln 7 raised to 3. Okay, minus 3 over 2 times x raised to 5 over 5, right? Plus 1 half x raised to 3 over 3. Okay, and then plus, again, we add 1 to the exponent 2, and whatever the exponent, that will be our denominator. This will be 1 half. Now this, the last one is the third theorem. So 1 half ln of x plus c. So we are now down to the final answer. So 7 times 7 raised to 3x is 7 raised to 3x plus 1 over, so using the property of natural logarithm, um, this will be equal to 3 ln 7, okay, minus 3x raised to 5 over 10 plus x raised to 3 over 6 plus ln of absolute value of x over 2 plus c. And that is our final answer. All right, let's go to the third to the last example. All right, are you still there? All right. Okay, so just like what I did earlier, what I'm gonna do is I will separate the terms here. So which means that this is 3x squared over 3x cubed minus 27x raised to 4 over 3x raised to 3 minus 3e raised to x over pi. Now again, that pi is a constant number in math. That's approximately 3.1416. Okay, so let's do this now. We can cancel the 3, right? So this will just be equal to 1 over x dx. And then minus, that's 9, so we can take that out. And then x dx. And then here what we can take out is that 3 over pi, because that's a numerical coefficient, e raised to x dx. You see that? Now you can see this is from the original problem. It looks like, oh, that's kind of difficult, but it's not really difficult. So equals ln of absolute value of x minus 9 x raised to 2 over 2 minus 3 e raised to x over pi plus c. And that is going to be our final answer. Alrighty. Alright, let's go to example number 9. Okay. So just like what we did in our example earlier, we need to multiply that 2x plus 1 and x minus 3 first. Okay? So again, this really looks complicated, but if you do it, if you think about it and simplify everything first, it's not going to be that complicated as it seems. All right, so what I'm going to do is we will use the FOIL method to expand that first. So 2x plus 1 times x minus 3 is equal to 2x squared minus 6x plus x. So 2x times x is 2x squared, 2x times negative 3 is negative cx, 1 times x is x, and then minus 3. And this is equal to 2x squared minus 5x minus 3. Okay, so this term, right, is just equal to that one. I mean this, the one on top, is just equal to that one. So what I'm going to do is I will separate those three terms first. So the first one is 2x raised to 2 over x raised to 3. Okay. No, I will do that later. I'm just going to separate them first. So minus 5x over x raised to 3 minus 3 over x raised to 3. There you go. And then actually we can simplify this one because the bases are the same. They are both e. We will apply the quotient rule of the loss of exponent. So which means x squared plus x minus 1 minus x squared plus 1. So that's x squared minus x squared. That cancels each other. X minus, there's nothing there. So that will give you e raised to x. And then negative 1 minus 1 is negative 2. So x minus 2. Alrighty. So this is equal to the integral of, oh, I'm going to take that out, that too. And then x squared over x cubed is 1 over x dx minus 5. This is 1. This is just 1 over x squared, right? 1 over x squared, or that will just be equal to x raised to negative 2. Let's just use that. And then dx, forget the dx, minus 3, and then x raised to negative 3 dx minus e raised to x minus 2 dx. Alright, so now let's finalize our answer, or let's integrate this. Okay, so this is going to be 2 ln of x. So that's the first one. Then minus 5x raised to negative 1. Negative 2 plus 1 is negative 1, and this is over negative 1. Minus 3x raised to negative 2 over negative 2. And then minus, it will just be e raised to x minus 2, and then plus c. Alright, let's finalize our answer. This is 2 ln of the absolute value of x. Now this is going to be plus now, because that's negative negative, and we want the exponent to be positive. So it will just be 1 over x. What happened to the 5? 5 over x. And then again, this will also be plus, and then 3. We want that exponent to be positive, so this is 2x squared minus e raised to x minus 2 plus c. There you go. All right, so let's go to the last example. Alrighty. So if you remember what we did in example number 9 with that e, see that e? That e raised to x squared plus x minus 1, and then the denominator is e raised to x squared plus 1. We can do that here and simplify uh, this term. All right. So that will just be equal to 2 x cubed minus x cubed is 0, negative x squared minus negative x squared is equal to 0. That's x minus, there's nothing there, negative 3 minus 1 is negative 4. There you go. So minus, okay, let's expand this first. So x squared, x cubed go. What is happening? X cubed minus x all over x raised to 4. All right. So now let's separate everything here using the fourth theorem. I'm talking about the fundamental theorems that I discussed in my previous videos. So this will be equal to 2 raised to x times 2 raised to negative 4 dx minus x raised to 3 over x raised to 4 dx plus, that's going to be plus x over x raised to 4 dx. All right, so we can take this out, by the way, this term, that's 2 raised to negative 4. So let's just put that outside. 2 raised to negative 4. There you go. Okay, so now this will be equal to, since that's 2 raised to x, so this is 2. What happened? 2 raised to negative 4 times 2 raised to x all over ln of 2. So 2 raised to negative 4 and then 2 raised to x. Okay, minus, this is just 1 over x right here, so that's 1 over x. So if it's 1 over x, that means that will just be equal to ln of x. All right, and then this will be equal to 1 over x raised to 3, which is x raised to negative 3. So negative 3 plus 1 is negative 2. So plus x raised to negative 2 all over um, negative 2 plus c. And then let's finalize our answer. So this is 2 raised to x minus 4 all over ln of 2 minus ln of x. Now this is going to be minus now because of that minus 2 in the denominator, and then we want the exponent to be positive, so 1 over 2x squared plus c. Alrighty, so that's how you solve, or how do you find the antiderivative of exponential functions. So I hope you learned something. Thank you for watching. Thank you for being patient. Have a nice day. Bye.